Ladies and gentlemen, welcome to Job Shop USA. My name is Keith and I'm your host today. We're in my shop here and we're getting ready to use our WAZER again. Today's project is going to be 3/8 stainless steel Cummins flanges. Now here is a sample. This is an actual manufactured made part that I've plasma cut and removed from one of the exhaust systems that I had to modify. And of course, this was a double-ended part, and we only needed one end, and I was modifying the curve and whatnot. And that is a very popular need in repowering and setting up new engines in older boats or even new construction, and having an issue where you can't use a stock elbow or 90 or whatever part you're using off of the turbo into the system that you have at hand. So I have been cutting these out of the plasma cutter, and this is my results from plasma cutting. And of course I do dress up the outside, and I have to machine the inside because we have welded pipe that we have to. This just happens to be a little piece, a sample that I always hang on to so that I can check that register to make sure that I have a good machining in that. But if you look at the front of the arc here, the front of your plasma cut or the top of your plasma cut, when this is on the table like this, gives you a nice entrance. But the exit on your plasma cutting is a little bit less than. So I usually have to dress this surface up with a rotary burr. And I don't have one here that's been rotary burred, but I do have samples to compare what I'm looking for in the Waterjet. So what we have here is a piece of 3/8 stainless steel, grade 316. And we're going to put this in the WAZER. All right, we're just dropping it down on the table and we're sliding it back into that register there. All right, now we're going to get a couple screws and we're going to hold the thing down. And it probably, this is heavy enough plate, it probably could cut out this whole part, because we're only going to cut a flange out of here, out of this section right here. But little light vibration and things like that, we might as well go ahead and anchor it down with a couple screws. The support bed is a plastic piece that it's like an extrusion almost. And anyway, I'm not sure exactly how it's made, but it has a set of holes all through it. And they figured the right screw kind of gives the right, let's just say like the tap size, okay? So you can kind of hit a couple different places here and hold your piece down. And all right, so we got two here. This is actually kind of holding. We're just going to put one in. We'll put one in over here just to know that we're not going to pop up. Okay, and we'll go ahead and put one over on this side here in the back. Okay, I doubt if that's going to go anywhere. Okay, let's set up for our cut here. All right, and we're going to go select cut file. We're going to come on down here to Cummins exhaust flange. Even though you level a bed here, the stainless steel, here's the shear edge here. It kind of rolls off, but we want to double check and make sure that in a couple other areas, we're not too close. Because I've found that if your bed is extremely off or you run into a situation where things start expanding or lifting the material, thin sheet metal, stuff like that, you will put enough pressure against the nozzle that you blow back through your hopper of material. All right. And so I'm just kind of checking a few spots here. It feels a little tight right there. So we're going to preset our material there. Okay. Now I'm happy with that. Now we're going back through the same process. We already know that the nozzle was high enough. We set everything there. Materials on, fasten material, set the nozzle height. Okay, we're gonna go down for a dry run. We wanna make sure that when we come around our flange that we're gonna be inside this area, this side over here. This is pretty nice. The upgrade on the Pro actually lets you go through this part of the program, and then if you've already cut some areas and you want to stop or come back to that same area and recut, or pause, go do something like you had to run, go grocery shopping for the wife or something, and then come back to it, you can come back to your cut position and then you can restart again. There's the inside circle, and then the one we're really looking for is the next cut here. Okay, so it's about a half an inch in from the backside there. And we're a good distance in from here. The nozzle's in the center of that cone. All right, I think we're ready to cut now. All right, it says closed door. Now I want to go ahead and get a video of this cutting inside the chamber here. So I'm going to add my GoPro here, and I'm going to turn it on. And I also got to turn on my remote. It'll take a second to resume there. Max video. Let's see. Um, let's go for what mode we want to be in. Max time warp. We'll put it in that. All right. I believe it's on. We're going to go from there. All right. And here we go. It takes a while for the pierce to go through 3/8 of an inch of steel, stainless, things like that. It's still piercing. All right. It has gone through. It's still leaving a little extra time for its piercing, but it has pierced all the way through. Now, they didn't have a setting for grade 316 stainless steel at this thickness, so I'm using a grade 304 stainless steel scenario that they have already programmed. Now, I had a choice of 3 settings as far as coarse, medium, or fine on the cut. The coarse would have been cutting 3/4 or 0.740 inches per minute. The length would be an hour and 37 minutes. And the cost overall, grit, garnet, power, everything, $25.44 to cut out this flange. The medium would have been 0.660 inches per minute, uh, an hour and 45 or 46 minutes long, 27.98, and we're cutting it at the fine, which would be 0.580 inches a minute, and it'd be 1.59 long, meaning 1 hour and 59 minutes, just under 2 hours. And the cost would be $31.21 to cut this flange out. All right, it's 99% here, so it's just about ready to shut off, and we'll lift up the door and rinse her off, and we'll get a good look at it. Here we go. There it is. All right, I'm going to pump out some water here and rinse down some sides here. Pumping out some more water here. Just wanted to get it down so I can rinse off the top layer here, and okay. It's a deep cut, so the sand's probably embedded in there pretty good. Um, that looks darn good. Okay, we're probably going to pull the plate up and pop it out of there and see if I can get a screwdriver in here first. We'll see what we can do. All right, we got a screwdriver and we pop this. And we're just trying to lift it out of here now. There we go. Okay, we had we had to start and stop over here on the back side, and it actually stopped because it was telling us we needed material at that point there, and we restarted it, and then we came back around, and anyway, the rest of it should pop apart. That looks fabulous, pretty cool. All right, and then we just gotta pull these parts out. Let me back you up here a little bit too close here. We may have to take a punch and break those loose. Stainless is pretty stout, even though it has just a little tiny tang down here that it's connected with. All right, let me clear this off, rinse it off, and we'll take a close look and compare the Waterjet flange with my plasma cut flange. The other day, I cut some 5/16 steel. Did a pair of dog links here. All right, now let's go ahead and we'll put you up here in front of you. And you can look at the finish. Now, these links here run in tandem like this. The swing arm of a motorcycle has got a suspension side and then a link side. And our customer wanted to try to shorten the links, drop the suspension down, give him more leg room. The bike was a little small for him for how tall he was. Okay, in all fairness, I had to set up the plasma table and actually cut out a fresh flange so that I had the same program cutting on the plasma cutter as I did on the Waterjet. All right, now these pieces here, I'll just fit back in there. So side by side, we're going to compare what I did on the WAZER and what I did on the plasma cam. I do, you know, if I didn't have the Waterjet, this is how I did these flanges. But I had to babysit this one while it was cutting more than I had to babysit this one. All I had to do was pay attention to the sand for the hopper on this one here for the duration of the cut. And this one here, every time it pierced, I would have to take my little putty knife and knock away the dross on the top so that it wouldn't catch. Because actually, I did have a situation where it did catch. It caught this dross right here and knocked the torch off, and I had to restart whenever you restart. And also, too, we were on a small piece of material. And when you're on a small piece of material, the heat makes the part move around. All right, so my cut was in non-uniform. All right. This is not bad. These can push out and knock out, but I just left them in there. The center, the same thing. It can push out. All right, but let's put that aside. I'm just saying that I have to babysit it, and I forgot that I actually had to babysit stainless steel after I cut this one with a Waterjet. All right, so let's take a look at the actual cut and dimensions off of these two parts here. The same file was used to cut both of these. Okay, first, let's take the plasma torch part, and we're just going to take dimensions straight across. There's 678, 680, 715, 700. All right, on the center, 674, 677, 669, 671. All right, now we're going to go out to this thin section out here on the outside. 252, 260, 310, 272. 249, 257, 255, 258. We're going to go ahead and take dimensions of the hole. 2998, 2995, 3027, 3030. Okay, we're going to go to the outside. We'll measure outside equal with these 4 points here. 5614, 5629, 5607, 5577. Okay, let's look at the surface finish. Okay, now the back side. And the front side. All right, now here's the water jet part. Here's the front side. Here's the back side. Very little difference between those. All right, one test that we need to do. This is the back side. Just to let you know, it doesn't matter if it's the back side, the front side. Here's the front side. This is the size fastener that's used in bolting this flange to the turbo. Oops. Okay, here's the okay, right here, this all narrow. I'd have to rotary burr in here. Here I'm not quite going all the way into there. It's going that far right there. That slot's pretty good. This was setting up. That one's not going all the way in. This one here again is the tight one. And it doesn't matter if you put it on the front side or the back side. It's straight in. That diameter has a little interference. This has got dross on both sides that really has to be taken down. This flange, I really don't need to chuck and turn the outside. I almost always turn and machine the outside of the plasma cut rings. They do look nice when I'm all done, but I'm saying that you probably get away without having to do that on this one here. The wall straightness, uniformity, and all that's pretty good. Here was something I was just playing around. The center goes in there, and our cutouts from the water jet actually all fit inside the original sample as well. Okay, I'm looking straight down on them, and you can see I left the pieces in here. You can see where the pierce points are. You can see the little pierce points over here, there in the center, there in the center. Okay. This piece here would have to be, if you were to reuse this piece here, let's just say drops, okay? Machining drops. This drop has a pierce point that's got to come in and then before it goes around. This pierce is almost right on the line, so this drop would finish off faster or in less time and a larger diameter. Okay, the question might be, why did I pick the fine instead of going with the medium or the coarse setting on the Waterjet to make the job go faster? Well, just like on the plasma cutting, I go for the quality of the cut on the edge over the speed. Every machine is going to have a certain range, and you're going to have a certain finish that's going to result. I'm going to show you what I have in these two parts and what I'm looking for. Let's just take that this is the torch and this is your arc coming down. A pierce is straight. And then when you start traveling, it actually leans somewhat like this because the top surface is being cut, but the bottom, the speed from here to there and that angle as you're traveling around is evident. I'll show you both pieces of these, and both are going to be cutting the same way because there's typical direction of cut, outside, inside, and whatnot. Okay, now I believe I can get this in focus there. All right, you see the slope of that looks pretty straight, and then it has a feather that leans out one way. Now pay attention to that direction. All right, here's the water jet. They both do it. Also, in the speed and the direction coming around, and depending on the wear of your nozzle, the swirling, dirt in your nozzle, all different kinds of things, and continually taking shape. And I'm sure that eventually I'll have to replace the nozzle on the water jet. With all that being said, if you're going to look at that trueness, when you're cutting, now I'm going to 180 it over on the other side of this part, and you can see that it's pretty square. All right, now here's the plasma cut one. You have a little bit more angle to the cut, and it will flip-flop from side to side. When you're drawing out your object that you want to cut, and let's just say that you want to be within 5,000, that's within range or realm, you know. When you pierce through and you're cutting from the top side, wouldn't you like the bottom side to be pretty close to what the top side is cutting? All right. The water jet, the WAZER performance was very satisfactory. It was right up there with my expectations. Done good. All right. I'm satisfied. This is now I have another flange that I can put up on my collection there so that when I have the repair projects and modifying projects for Cummins exhausts, we also do a different size hole here for the street version. But in the marine version, they're running 3-inch. All right. So I'm extremely happy with my capabilities of getting up to 3/8 of an inch thick on that stainless steel. That's pretty impressive. Now, I have some other alloys, and we're going to have some more videos coming along where I want to get up, and I'm supposed to be able to do 1-inch aluminum on this. And I'll be bringing that. I do have an 1/8 aluminum project coming in. Actually, I have it on the bench right now, and it's actually something that we cut out our first part back in our desktop, and we're going to be cutting the same part, same file. We just hunted it up, and we're going to be doing that in another video as well. Also, I'd like to bring you in, and just because of my first video, I installed a shelf on the side of this WAZER. All right, back in the first video, I was showing you the installing of this shelf on the side of my WAZER. And I'm humble enough to let you know that I screwed up. First off, this is not a shelf. This is a tray. What is a tray versus a shelf? Well, a shelf is just flat surface, and a tray is a shelf that gives you lip. All right, so there's 1.75 inches of a lip here, so that when you pile stuff up here, it comes up 1.75 inches before you have that slide off effect. All right, so the one reason why you want it to be a tray versus a shelf is you can reach underneath here very easy for the on and off switch, and also the water drain switch here as well. Um, you can see I already it collects. Trays collect things just as fast as shelves. They just hold things a lot longer before they actually start coming off. All right, until next time, thanks for visiting Job Shop USA. Get her done.